Hi everyone, my name is Leif Kvarnes. I am a senior physics major at Randolph College. The research I'll be presenting today is on the tribology of antimicrobial surfaces and was first started as a Randolph College summer research project and was further developed for my senior capstone research. First off, what does that mean, tribology of antimicrobial surfaces? Well, tribology is the study of wearing surfaces. It is an engineering field that focuses on how well things wear out, how they break down, and when they need to be replaced. The things that are being worn down are antimicrobial surfaces. What are those? Well, antimicrobial surfaces are synthetic materials which passively destroy any microbes and bacteria which are deposited on them. These surfaces are known to work really well and do a fantastic job at mitigating contamination and disease spread. What isn't well understood is how they work over time. They get worn out in the field. People's hands are touching them, depositing oils, they're out in the weather. And while initially they work great, we're not sure how they work after 6 months or a year. To get an answer to this question, I built two machines which systematically and reproducibly wore these materials out. These two machines can be shown in the middle of the poster, and they're basically a rubbing machine and a pressing machine. These machines were programmed using a Raspberry Pi running the operating system Raspbian and were coded in Python. The first machine is a pressing machine. It works by pressing straight down on top of a sample. The scale at the bottom of the machine records when the correct weight was pressed, and then it retracts up. And that process was repeated for the number of times we wanted to wear out that sample, 10,000, 20,000, whatever we wanted. The second machine was a rubbing machine. Kind of works on a similar principle. It is a sander that oscillates back and forth slowly over the surface, and that gives us sort of the motion of a person's hand sliding across it. The goal here was to isolate the two motions that these samples would be undergoing and get a good idea for what these samples would actually be experiencing while in the field. The results of these experiments can be seen in the graph on the top right of the poster and show that initially the samples were working optimally, 100%, brand new, but as they were abraded, they dropped in efficiency to about 70% of what initially they had. That 70% held pretty constant for most of the presses after that, and we actually didn't see any drop even at increased numbers. That data is still coming in, and this research is still ongoing. So the initial results seem to indicate that these products are very long-lasting, and they have great potential for implementation in a wide array of applications. I've been Leif Kvarnes, and thank you for listening.